Hello everyone, my name is Ravi Joseph and today I'm going to be talking about the protein interleukin 10, or as we will refer to it from now on, IL-10. So what is IL-10? Well, imagine that you wake up one morning and you find out that you're sick. You go to your doctor's office and find out the cause of the sickness is a pathogen. When your body is attacked by a pathogen, rapid activations of pro-inflammatory cytokines occur. Now, these are great because they help fight off illnesses, but too much of this can lead to tissue damage and other nasty stuff, as you can see here. Anti-inflammatory mechanisms are put in place to prevent the aforementioned tissue damage and to maintain/restore tissue homeostasis. IL-10 is an anti-inflammatory cytokine produced as part of these mechanisms, and a powerful one at that. IL-10 is encoded in chromosome 1, and it is produced mainly in leukocytes, or white blood cells, although other cells such as Kupffer cells, Hofbauer cells, and macrophages also produce it. After it is created by the following cells, it binds to its receptor made of IL-10Ra and IL-10Rb, and triggers phosphorylation of STAT3, which proceeds to translocate to the nucleus and cause a process which inhibits pro-inflammatory mediators. It also interferes with antigen presentation by reducing expression of MHC class II and co-stimulatory molecules. So how is IL-10 synthesized? Well, now we're in a predicament. Right now I'm just a dismembered voice. How do I show you this in real life? Oh no! What? A body? Cool. Now I can show you my path of a protein model in 3D. Let's start with the nucleus. In the nucleus, the mRNA for IL-10 is transcripted. It then leaves the nucleus and attaches to a ribosome in the rough ER. Once it attaches to this ribosome, it is translated and synthesized into an IL-10 protein, albeit an unfinished one. Once this occurs, it travels through the rough ER and is sent through a transport vesicle into the Golgi apparatus. Here, it continues its path. The IL-10 is then folded and is prepared to be sent outside of the cell. Once it finishes its pathway, it is sent through a secretory vesicle outside of a plasma membrane and into the bloodstream, where it's ready to do its job as an anti-inflammatory cytokine. The structure for a completed IL-10 protein looks something like this. As you can see, no beta sheets are used. Only alpha helix proteins are used in the construction of IL-10. I feel weak. I'm back? My work as a human must have been done. Anyways, the IL-10 protein is great, but what happens if something goes wrong? Well, one example would be very early onset irritable bowel syndrome, or VOIBD. VOIBD occurs in children under the age of 6. It is different from regular irritable bowel syndrome in that it usually is caused by an underlying monogenic etiology or primary immune deficiency. Children with VOIBD also undergo much more severe symptoms such as severe colitis, severe perinatal abscess, oral ulcers, etc., and respond poorly to traditional treatment of IBD. People with VOIBD tend to have mutated IL-10 receptors, primarily in IL-10Ra, but also in IL-10Rb to a lesser extent. In the example I studied, these mutations cause aberrant splicing and misfolding of IL-10R1, resulting in impaired expression of IL-10R1 at the plasma membrane and defects in IL-10 signaling. This decreased efficiency of IL-10 signaling is what caused VOIBD in patients. Here's the helix structure example that I used for IL-10, and here are my works cited. Thank you so much. I hope you learned something and have a great day.